So I'm Stefano, privacy architect at Here Technologies. We are a location data company.
And I'm Engin Bozdag. I'm from Uber, Uber, a rideshare food delivery company. All right, so today we're going to talk about challenges in doing technical privacy reviews, and then how LLMs can help us to automate some of the workflows. Then we're going to present an experimental framework testing LLMs and results from a proof of concept, and we'll also discuss the future steps. So technical privacy reviews essentially focus on the review of an architecture document. And this typically contains things like the scope, the purpose, function and non-function requirements, and the actual data flow, software components, alternative architectures, libraries, and other artifacts. If you're lucky, there is also a privacy section dedicated to personal data, recipients. There's a security section and some other interesting details, including monitoring and logging. And this is an engineering document written for other engineers. So, as a privacy engineer professional, you need to do a deep reading and understand what the privacy risk is, and maybe ask questions to others. To the authors of such documents. So this is typically involved during the engineering design phase, where different design choices are checked, and ideally the output is an updated architecture. So this is not a compliance assessment, but a technical assessment. The purpose is, again, giving engineering advice and shifting privacy left. But there are some challenges doing these reviews. One, they can be very time-consuming. Reading a lengthy document, understanding privacy risk, that takes time. And in an organization where there are many feature updates, it could take a lot of time. You can get hundreds of these documents to review every week. And some of them will be low risk. They wouldn't actually be handling personal data. Others would have a high privacy threat. You typically have limited resources in an average organization to do this. I know some companies don't even have privacy engineers doing such reviews. And it is, you need to find someone who understands architecture, but also privacy. And finally, the documentation might not always be complete, and the quality of the reviews themselves might vary. So how could we use automation here? Our goal is, to figure out how do we dedicate these limited resources and let them focus on high impact and high risk activities, but without just, blindly, adopting LLMs, but ensure there is expert judgment in place as well. So we are trying to reduce false positives. So, initiatives that doesn't actually have privacy risk, but enters our funnel. Also reduce false negatives. So those who don't enter our funnel but actually should. We want the SME to provide feedback on the tool, have dashboards, have metrics, and also potentially extend this to other domains, because review is a review. There could be also security reviews, maybe compliance reviews. And how do we achieve that? So Stefano will talk about our experimental setting.
Thank you. Yeah, so let me start with describing the datasets that we used. We took technical documentations from Here and Uber, 82 and 60 documents respectively. The datasets were balanced, so we had half of the documents which had at least one privacy risk identified, the other half none. And those documents have been filtered for completeness, so we did not include documents that didn't have enough information to come to a conclusion or assess the risks. We tested these documents on different models. So on the Here side, because of confidentiality reasons, we tested on locally deployed models, Mistral, there's a typo there, and Llama 3. And on the Uber side, the test was performed using GPT-4. I'll talk about labels and how the metrics that we employ. So we start with the technical documentation. We had a privacy engineer review each document and label them according to whether a full review was required. Then we had for each document a team of privacy engineers review them and then label them according to privacy labels. So these labels are identifying specific risks, and we use these labels as our ground truth in the analysis. Then this technical documentation was given to the model for data extraction, which will produce the technical summary. And then at the end of the pipeline, the model produced an output, which is a textual, a piece of text that describes the identified risks, and a binary label, again describing whether a full review is required or not. With those labels, we compute or we evaluate three matrices. One is the factuality of the documentation. So we compare the technical documentation with the technical summary and evaluate whether there are any hallucinations or everything is factually described there. And then we compare the ground truth against the binary labels for the human and for the model to look at the accuracy of these labels. A brief description of how we measure accuracy. So accuracy, we measure via precision and recall. Those are standard metrics in machine learning. They look at different aspects of privacy. So precision, for example, you can achieve perfect precision if you label all of your data set as low risk, except the one obvious privacy risk. In that case, you'll get perfect precision. Recall, instead, you get perfect recall if you label everything as high risk. So to balance these two perspectives, we compute the F1 metric, which is the harmonic mean of these two. So it gives us a trade-off between these two perspectives. This we use to measure accuracy. And here I'll describe the scorecards that we use throughout the presentation. In this case, I will show human results. So we are comparing one privacy engineer against a team of privacy engineers. And as you can see, the accuracy is very high, as measured by the F1 score, but it's not perfect. So we have some time wasted in reviewing documents that are not required to be reviewed, which we measure as the false positives. But we also have missed risks, which we will measure as the false negatives. During the evaluation, we evaluated two approaches, the single prompt approach and the gated approach. The single prompt approach is quite straightforward. You take the documentation, you give it to the model and ask the model to show the privacy risks, and then you get as output the text and the privacy risks. The gated approach is more complicated, so you split the task in multiple steps and you provide different inputs to the model to basically subdivide the task in smaller tasks. The idea to simplify tasks is to reduce the confusion of the model and also reduce the context size. There are some papers in the literature that point out how reducing the context size and also splitting the task in multiple tasks that are simpler actually improves the reasoning ability of the model. But before deciding which one, we evaluated the single prompt approach because the disadvantage of using a gated approach is that it's more costly. You have to run the model multiple times, so the costs increase. So first we evaluated the single prompting, and we find that the accuracy is quite low, and there is a lot of time being wasted. This is because the model tends to label everything as risky. It's very conservative. Does not consider the likelihood of risk, so it labels as risky something that might be very unlikely to happen. And in some cases, it does not identify concrete risks at all. So after this, we decided to go for the gated approach and we evaluate that. And now I'll walk through the results of this proof of concept. First, we look at the factuality of the model. This is evaluated with Mistral, and Llama 3. How we label this data set, we label a document as factual, a summary as factual, if the model output is mostly factual and correct with respect to the technical documentation. Minor if the incorrectness, so there are some imprecisions that do not impact their privacy risk assessment. An example would be that the model misinterprets a privacy regulation but still classifies the risk correctly. And major when the incorrectness impacts the privacy assessment. For example, the model could say that a certain processing is high risk because GPS coordinates are processed, when, for example, these GPS coordinates are not related to an individual. So, forgot. So here we see that the models are typically producing factual answers, and all of those models are producing non-factual answers. And interestingly, the bigger the model doesn't mean that it's more factual. But still, we can conclude that the models are mostly reliable, except for a few cases. And here are the scorecards for the models. From a first glance, we see that GPT-4 performs the best with the highest accuracy and the lowest time waste. While the other three models, they are somewhat comparable, achieving more or less the same performance with small variations. And again, here, the larger model is a bit better, but not so much better. And in all cases, we see that there are a small percentage of missed risks and a varying percentage of wasted resources. One thing to note is that we compared, so we evaluated GPT on the Uber datasets and the other model on the here datasets. Therefore, they are not necessarily comparable, these numbers, but they should give us an idea of the trend. And now I give it back to Engin for talking about the future.
This was a proof of concept, so if you would want to productionize it, one of the factors is the cost. We have some detailed explanation in the slides later for those interested, but the GPT-4 is considerably more expensive than other models due to the pricing on the number of tokens. It still comes cheap if we compare it to an average human who would do all these types of reviews, assuming a human can do a review after another. But it's not just, it's cheaper, but this would allow the privacy expert to invest their time in other things rather than reviewing each and every document individually. And if you would want to, again, take it to more production, one area where it could be improved is on the input preparation. For instance, you don't want to send the entire document due to cost and maybe security reasons. So some text extraction and filtering will need to be in place. Maybe also be able to transcribe images and then feed it into model, which might also help with the identifying privacy risk. Also implementing flowchart readers. The gates, so these different sub-risk areas, ideally you don't want it hard-coded into the prompt, but also define it in a machine-readable config file, which you can also use it to extend to other domains. When the model cannot make a decision, that should come to the review of the privacy subject matter expert. But also the subject matter expert should be able to give feedback and do audits into existing assessments, and which might lead to improving the prompt. And finally, the model should be validated continuously, because maybe the prompt works today with the foundation model offered by your vendor, but maybe over a year it doesn't work anymore. So having a golden data set and testing it continuously will make sense. Obviously, if you would want to take this in your organization, you would be competing with other AI initiatives. So I'm adding some KPIs here. For example, you can measure the reduced time spent as reviews by looking into word count in the entire document, which can be 20 pages versus the output, the summary provided by the document. Some others, including cost savings or missing information identified by the model, which can be measured by documents with inconclusive results due to missing information. So conclusion, these tools have the potential to be useful assistants in triage, but not necessarily replacing the entire review flow. And mind you, this is not just reducing number of reviews, but also you already do probably some sort of filtering for the incoming reviews to your funnel, but you don't know what you're missing there, right? If you solely rely on engineering input, do you process personal data? Do you share it? The answers might not be accurate. So these tools can be used there to catch those false negatives. The models seem to have more false positives compared to false negatives, so that seems to be the bigger challenge. And as we have demonstrated, not every model is the same in terms of accuracy, cost, and security risk. And finally, this is a question we get a lot, like, what if the model misses? What if the output is wrong and your human doesn't review? Mind you, these are design reviews, and in many organizations, you would also have a product readiness review or a pre-launch review where such things can be caught. It would be more costly because now implementation is already done, so you would need to do redesign. But so that could be a backstopper there. This was a team effort, so these are all the people involved in both of our organizations. And this is it. So thank you for your time, and we're happy to answer any questions you might have.